Hi, everybody. This is Johnson, and I'm in the IT industry for the last 11 years. And I work as an architect for one of the largest MNCs. So prior to giving trainings in blockchain, I was giving trainings in IBM Mobile First, which is a mobile application development platform, and I also delivered a couple of corporate trainings. Okay, so let's start with the blockchain. So before we talk about what is blockchain, I want to talk about what problems blockchain can solve. Okay, so let's talk about intermediaries. Okay, intermediaries are middlemen. They play a major role. Okay, in the role of global economy. Okay, so these guys facilitate the transaction of goods and services by creating trust and certainty. Let's take the example of real estate. Okay, so who owns the who maintains the records of who owns a particular house? Okay, if the ownership of a particular house changes, where that is getting recorded? Okay, who holds the legal rights of a particular house? So in this case, it is local government authorities. Okay, and think about in similar way, who owns the legal ownership of a particular car or a vehicle? Okay, so here in this case, again, it is certain government authorities. Okay, now think about finance industry. Okay, think about money transfer. Okay, so this is the role of intermediaries in every business. Okay, irrespective of the industry, intermediaries or a middleman play a major role in the global economy. So now let's think about what advantages one can get by eliminating these middlemen or intermediaries. Okay, so let's talk about international remittance. So international remittance is nothing but a foreign worker or an immigrant worker trying to send money to his homeland. For example, in India, there are a lot of people, immigrants who are working in Dubai or Saudi Arabia or United Kingdom. If the immigrants send the money back to India, that is called international remittance. Okay, so now let's see an example where Alice, okay, is trying to send Bob $5. Okay, and now Alice, let's say she is in Russia and Bob is in Japan. Okay, so Alice is trying to send $5 from Russia to Bob, who is in Japan. Okay, now this transaction cannot happen without a trusted third party. Okay, a trusted middleman. Okay, now what are the problems with this approach? Okay, so it takes around 3 days for this transfer, as well as there is a lot of fees for the transaction to happen. Okay, so there are two problems here. One is the delay and as well as the transaction cost. Here in this case, the trusted third party, you might be knowing, you might have sent some money from some foreign country to India. It could be a Western Union money transfer, or it could be a MoneyGram, or it could be a bank that facilitates this transaction. Okay, so now this is one of the problems the blockchain can solve. The international remittance is something blockchain can solve. Okay, now let's think about how this can be achieved using, let's say, Bitcoin. Okay, so if I want to send my friend 10 Bitcoins in Australia, all that I need is his public key or the public address. If I have his public address, I can send 10 Bitcoins, okay, to him instantaneously without weeks of delay. Okay, and coming to the transaction fees, on an average, the fees per Bitcoin tend to be around 0.001 to 0.003 BTC. So this is a very, very low amount. Okay, to give an example, a person sent around $99 million worth of Litecoins. It happened very recently. This transaction took only $0.40 in fees, and the transaction took only 2.5 seconds. Okay, so the transaction fees for a transaction worth $99 million is only $0.4, and it took only 2.5 seconds. Okay, so this is what this is one of the problems blockchain can solve. Okay, so coming back to the international remittance, it is estimated that in 2017 the international remittance was around $600 billion. Okay, and India accounts for $65 billion remittances and retaining the top spot. So you can imagine how much a country like us needs blockchain. So now let's try to define blockchain. Okay, so blockchain is a technology that enables movement of digital assets or currencies from one individual to another individual. Okay, and with blockchain you can send money directly to someone else without going through a third party like a bank or a payment processor. So you can avoid the middleman. Now, trying to generalize the blockchains, in a general sense, a blockchain technology removes the need for a middleman in contracts and transactions. Now, let's observe this word contracts and transactions. So, which means it need not be related to cryptocurrencies. It may not be related to money sent from one individual to another individual. It could be any contract or a transaction. Okay, so with this definition and background, let's start looking into the history of the blockchain. Okay, so the Bitcoin white paper. Okay, before we start, before we talk about blockchain, we must talk about Bitcoin, because before Bitcoin there was nothing called blockchain. Okay, so Bitcoin popularized the blockchain. So we can't talk about blockchain without talking about Bitcoin. Okay, let's start with Bitcoin. So the Bitcoin white paper was published by Satoshi Nakamoto in 2008. And he described it as a peer-to-peer money or electronic cash. Okay, and he made the whole Bitcoin source code as an open source. So which means anyone could take the protocol or a source code and fork it. So which means they can create their own version of cryptocurrency or a P2P money. And since Bitcoin, so many altcoins emerged. Altcoin means it's a term that refers to any other coin apart from Bitcoin. Okay, it's called alternate coin. Okay, so many altcoins emerged. If you look at coinmarketcap.com, so there are around 1,600 altcoins currently listed in the market. Okay, so many altcoins emerged and tried to be better, faster, and more anonymous than a Bitcoin. Okay, so everybody claimed to be better than Bitcoin. Okay, and some projects also tried to alter the idea of blockchain beyond the use case of P2P money. What this means is, so as I said, Bitcoin started blockchain. Okay, and Bitcoin is a P2P money, or it's a cryptocurrency. Okay, and a lot of people created a fork out of the Bitcoin source code. Okay, and they created something like a Litecoin or a Bitcoin Cash. They are also cryptocurrencies. But some people, some projects try to alter the idea of blockchain beyond the use case of P2P money. So, for example, Ethereum, okay, which is not only a cryptocurrency but can also be used for recording any transaction. Okay, so with the emergence of Ethereum, blockchain separates from Bitcoin. Okay, and the largest difference between the two is that Ethereum can record other assets such as loans or contracts, not just currency. Okay, so Ethereum can use to build smart contracts that can automatically process based on a set of criteria established in the Ethereum blockchain. Okay, to give an example on this, you can write a smart contract something like this. Okay, so if you want to give a house for rent, okay, you are the owner of the house, and you can write a contract something like, if somebody pays me $1,000, I can give them the house key. Okay, so this is a kind of an example of a smart contract. It meets the conditions. Okay. Now, private blockchain projects came into picture, and Hyperledger is one of the examples. Okay. There are two types of blockchains. One is public and private. So in this demo, we would be talking most about public blockchains, as well as we will be talking about private. But the difference between these two is that, as the name suggests, public is something anybody can join and anybody can participate, whereas in the case of private, only certain individuals who has the permission can participate in the blockchain. Okay, and there are a lot more differences between a private and a public blockchain, but that's for another day. Now, with this background information, let's start the introduction to blockchain. Okay, so what is a blockchain now? So blockchain is often described as a distributed, decentralized digital ledger. Okay, so now, so let's talk about what is a distributed and decentralized and digital ledger. So digital ledger, so you might be knowing what is a ledger. So ledger is a book that contains or that maintains all the ledger accounts and corresponding details in a classified and summarized fashion. For example, it contains all the ledger accounts with information, with columns like debit, credit, and the remaining balance. Okay, so this is called a ledger. Ledger is a normal book. Now, what is a digital ledger? A digital ledger is a computerized ledger. Okay, it's a file that contains classified form of all the accounts, and typically banks uses this information for deriving the account statements. Okay, so now digital ledger, you know what is digital ledger, right? Now this digital ledger is distributed and decentralized. Okay, so distributed means every node on the network, as you can see in the picture, has its own copy of the digital ledger. Authority that governs this network. Okay, now let's talk about what are the problems with the centralized systems. Okay, we are saying it's a decentralized and distributed environment. Now let's talk about what is the problem with the centralized systems and what are the benefits of distributed systems. Okay, so here you can see this is how a distributed and centralized systems look like. Okay, so in the case of distributed systems, you can see every computer on the network is connected to other machine. Okay, whereas in the case of a centralized system, you have all the machines connected to a centralized system and a server. Okay, now let us try to list out all the pros and cons, okay, based on certain criteria like security and scalability and trust. Okay, for example, in the case access to the server with the information, any data can be added, changed, or removed. Okay, so in the case of a centralized system, okay, if the server is compromised, then they can change the data, add the data, and remove the data. Okay, now let's talk about reliability. If there are a number of requests, the server can break down and no longer respond. Okay, so as far as the reliability concerned, centralized system has less reliability because there is only one server having all the data. If the number of requests increases, the server can break down. Now let's talk about scalability. Centralized networks are hard to scale since the capacity of the server is always limited and the traffic cannot be finite. Now let's see how the distributed systems can address these issues: security, reliability, and scalability. So now talking about security for a distributed system, all the data is distributed between the nodes of the network. Okay, if something is added or edited or deleted on any computer, it will be reflected in all the computers of the network. Okay, so since there is no central authority or there's no centralized storage of the information, even if a particular system is down, or even if data is getting corrupted in a particular system, there won't be any impact to the network because the data exists. in all the computers, in all the nodes. Now let's talk about reliability. And all the nodes of the network have the data. So the requests are distributed between the nodes. Therefore, the pressure doesn't fall on one computer, but on all the networks. So in this case, the total capacity of the network is much larger than the centralized systems. So the reliability of a distributed system is much better than a centralized system. Now, coming to the scalability, distributed systems don't have the problem of scalability like a centralized system. Distributed systems are infinitely scalable. Okay, so so while you are trying to add more nodes on the network, it will not affect the scalability of the network. So now let's come back to the definition that we have given. The blockchain is often described as a distributed, decentralized digital ledger. Okay, so now, as I said, every node on the network is equally empowered. There is no administrator as such in the network, and every node on the network has its own copy of the digital ledger, and there is no central authority to it. Okay. Now, in this kind of an environment, how does nodes communicate on the network, or how does accounts communicate on the network, and who updates this ledger, and how the consensus is maintained? So let's try to answer these questions. So the first question, how accounts communicate on the network? So now, cryptography. So you might have heard of it. Public key cryptography is a technique by which accounts communicate with each other. Okay, so to get deeper into it, when a person joins the network, okay, a blockchain network, he will get a public key and a private key. So public key is 34 bits and private key is 64 bits. And okay, now let's see how the accounts are maintained in the blockchain. Okay, accounts are not mapped by the names, but rather they are mapped to a cryptographic alphanumeric addresses. Okay, for example, we take the example of Bob sending 10 bitcoins to Alice, but in reality, accounts are not mapped to the names. Okay, accounts are always mapped to the public keys or public address, as you can see the table. Okay, they are alphanumeric. Now, how accounts communicate with each other? Okay, so a person can initiate a transaction by broadcasting the message by using his private key. Okay, so now you know what is public and private key. So we haven't talked here in depth about public key encryption, but you know, every person who joins the network will have a public and private key, and key is used for broadcasting a message, or is used bitcoins to somebody. Then you initiate a transaction, okay, by using your private key. Okay, now once a person broadcasts or initiates a transaction using private key, the network validates the transaction by checking whether the signature was made with the private key, which corresponds to the public key. Okay, so which means the network validates the transaction without knowing the private key of that particular individual. So this is the beauty of blockchain. So a person who is sending some money will publish an intention or broadcast a message with using his private key, and the network validates whether he is the rightful owner of the transaction or not, okay, by using his public key. So the network validates the transaction without knowing the private key. Remember, private key is supposed to be secret, so you should not really reveal it. So we will only expose the public key, but the network can validate the transaction using your public key. So now let's come to the next question. Who updates the ledger? The ledger to be updated one at a time so that others can take the update and agree. So this is one of the key things to remember. So because there are a lot of multiple people in the network, and every node people are trying to update the ledger at the same time, it can lead to conflict. Okay, so one of the key things we need to remember is ledger needs to be updated by one at a time so that others can take the update and agree. And this is achieved by using a specialized computers called miners. Okay. Now let's see who are miners. Miners uses special software to solve self-adjusting math problems and are rewarded certain number of coins in exchange. Okay. So we will discuss what is the self-adjusting math problem in the next slide. For now, you think about miners or uses special software to solve mathematical problems, and this is also known as proof of work, and are rewarded certain number of coins in exchange. Okay. Now let's see what is self-adjusting. Math difficulty, the difficulty of the puzzle, is adjusted based on the hashing power of the miners. Okay, to give an example on this, when Bitcoin was initially started, normal CPUs were used to mine the Bitcoins. Okay, and after some time, people started using the graphics processing units, that is GPUs. The moment people started using the GPUs, the math difficulty started increasing automatically. And after a few years, people started using ASSI. Okay, so this is application specific integrated circuits, ASIC. Okay, so these are specialized devices invented for Bitcoin mining. So the moment ASIC came into picture, the difficulty of the math problem increased. Okay, so this is what it's called self-adjusting. So the math difficulty is adjusted based on the number of miners or based on the hashing power of the miners. Okay, if more and more people are bringing more powerful systems in the network to mine the Bitcoins, the puzzle, the mathematical puzzle, the complexity of the puzzle will increases automatically. Why this is like this? So this is to ensure only one miner solves the problem at a time and happens consistently at every few minutes. Okay, this is to check the economy. For example, if this is not self-adjusting math problem, then people can validate the transactions much faster. What will happen is that more people get more and more incentives with this kind of Bitcoins, because every miner, when he solves the problem, he will get some Bitcoins. Okay, so the economy of the Bitcoin, the number of coins in the Bitcoin network increases so much. They don't want this to happen. Okay, so this self-adjusting math problem exists because they want to ensure only one miner solves the problem at a time and happens consistently at every few minutes. Now, what is the benefit? As I said in the previous slide, whoever solves the math problem will get a chance to publish the block onto the network and also gets rewarded. Okay, so what this means? Okay, so earlier we tried to answer the question, who updates the ledger? It's miners. Okay, and how a miner is chosen is based on whoever solves the math problem. Okay, whoever solves the math problem will get a chance to update the ledger. Okay, we will talk about publishing the block and all that in the next couple of slides. For now, you just understand whoever solves the math problem first will get a chance to update the ledger, and also in exchange they'll be given certain number of coins. Okay, so this way money supply is transparent and predictable. Okay, so in the case of Bitcoin, a new block gets created for every 10 minutes. So which means the transactions are validated for every 10 minutes and returned to the blockchain. Okay, And this also provides a smart way to issue the currency and also creates an incentive for more people to mine. Okay, so this is the benefit. So now let's try to answer the questions that we have asked. How accounts communicate on the network? So how accounts communicate on the network is using cryptography. It's a public key cryptography. And who updates the ledger? The ledger is updated by miners. And how the consensus is maintained? The consensus is maintained by a concept called proof of work. Okay, so now let's try to pose more questions. Why we use the term blockchain, and what do they contain? Okay, what do blocks contain, and how the security is ensured in the blockchain. Okay. So why blockchain and what do they contain? It's a blockchain because it's a chain of blocks. Okay, and each block contains a time-stamped batch of transactions to be included in the ledger. Okay, blocks also include details like the total number of coins, including the increase of coins, etc. And the transactions on the blockchain are signed digitally using public key cryptography. Okay, so a block, it's a chain of blocks. That's why we call it as a blockchain, and each block will have certain number of transactions which are time-stamped as well as digitally signed. Okay, now let's continue on the same question. What does blocks contain? Each block contains three types of data. We said blocks contain transactions, but it contains three types of data. And the first one is the data itself. The data is nothing but list of transactions. And it also includes hash of the previous block and hash of the current block. Okay. What is the hash of the block? Hash of the block is like a unique identifier. Okay. And it is unique in the network. Okay. And it also contains the hash of the previous block. Okay. Let's see in the next slide. Okay. This will explain you how the blocks are kind of backlinked. Okay, now I'm trying to answer the question, what secures the blockchain? Okay, so as you can see, the third block on the network contains the data, the hash of the previous block, and the hash of the current block. And the second block on the network contains the data and hash of the previous block and the hash of the current block. And the first block on the network, which is called the Genesis block, contains the data and hash of the block, but it doesn't contain the hash of the previous block because this is the Genesis block. Let's see what is the use of hashing. So hashing is a mechanism by which you can tell if something has changed. So if you tamper with any block, the hash gets regenerated. This makes the whole blockchain invalid. For example, take in this place, the middle block is tampered. Okay, and what it does is when something gets changed, the hash of the block is again regenerated, which means now the third block, which was containing the hash of the second block, needs to also change. Okay, so now by tampering the middle block, you are you are making all the following blocks invalid. Okay, so this is one of the security mechanism within the blockchain. So if you tamper with any particular block, all the following blocks will become invalid. Okay, so now, is this enough? This hashing mechanism, is this enough to secure a blockchain? So the computers has the ability nowadays to calculate the number of hashes per second, hundreds of hashes per second. So you can tamper with one block and recalculate all the hashes of the other blocks to make the blockchain valid again. Okay, so to mitigate this risk, blockchain has a concept called proof of work. Okay, so if you tamper with one block, you need to calculate the proof of work for all the following blocks. So you know what is a proof of work in the previous slides. So proof of work is nothing but it's a mechanism where specialized computers called miners solve mathematical puzzles to publish their block onto the network. Okay, so the tampering a particular block, okay, doesn't ensure full security of the blockchain. But if you tamper with one particular block, you need to also recalculate the proof of work for that particular block as well as for all the following blocks. Okay. And what else? What else secures the blockchain? So every block that gets created will be published, and every node on the network validates it again. Okay. See this example. So now, once the miners create a block and publish the block to the network, and those blocks will be published to the network, means every node on the network takes those blocks and again agree. If a particular block is tampered, they will be rejected by the nodes. Okay. So to successfully tamper with a blockchain, you will need to tamper with all the blocks, okay, and redo the proof of work for all the blocks, okay, and take more than 50% of the peer-to-peer network. So if you want to tamper with a blockchain, this is how you can tamper it. Okay, so you need to calculate. You need to kind of tamper all the blocks. Okay, calculate all the hashes, redo all the proof of work. Okay, and take more than 50% of the peer-to-peer network in control. So this is quite impossible. So now let's try to answer the questions we asked earlier. So why the term blockchain? Because it's a chain of blocks. What does blockchain contains? It contains the transaction, it contains the hashes, as well as it contains the details about total supply of coins, etc. And what secures the blockchain is hashing, proof of work, cryptography, and being distributed. Okay, so this is how it works. Now I have come up with an interactive slide. Let's say Bob wants to send, okay, initiate a transaction. It's like he can send some money to somebody, or he can do any transaction. When Bob joins a blockchain network, he will get a public key and a private key. Okay. To initiate a transaction, he needs to supply his private key as well as the transaction details. Transaction details are nothing but the amount of money as well as to whom you are trying to send the money. Now the blockchain program generates a digitally signed transaction, okay, and broadcast that transaction to the network. Now the network, okay, validates the transaction. Who validates this transaction? Miners does it, and they include the transaction in the block, and they publish the block to the network. Okay, so this is how the flow happens. Now with this information, let's try to define a blockchain. So a blockchain is a decentralized, distributed, public digital ledger that is used to record transactions across many computers so that the records cannot be altered retroactively without the alteration of all the subsequent blocks and the collusion of the network. Okay, as you can see, the 51% attack that we discussed, in order to successfully tamper the blockchain, you need to take more than 50% of the network in control, and you need to do the proof of work, okay, and as well as take, create number of hundreds of hashes. Okay, another definition here, the blockchain is an incorruptible digital ledger. So once something gets recorded to a blockchain, that cannot be altered. That is one of the key features of a blockchain. Okay, so now with that information, blockchain is an incorruptible digital ledger of economic transaction that can be programmed to record not just financial transactions, but virtually everything of value. Okay, so not just you can use the blockchain not just for cryptocurrencies, but you can also use this for recording any transactions. Now let's talk about the limitations and concerns of blockchain technology. Okay, as you can see in the previous slides, one significant limitation is called 51% attack. Okay, so that we already discussed. So this this was mentioned by Satoshi Nakamoto when in his Bitcoin white paper. It's called 51% attack and refers to a situation when a group of miners somehow take the control of more than half of the blockchain network's computing power. Okay, this is one of the limitations of blockchain. And now let's talk about power consumption. Let's take an example of Bitcoin mining. So Bitcoin mining now uses more electricity than 159 individual countries. Okay. Now, as per this diagram, Bitcoin consumes electricity equivalent to Colombia or Switzerland. Okay. So there is again this is one of the biggest concerns of cryptocurrencies specifically that uses blockchain, and this is one of the controversial topics, and there is a counter argument again, like we need to consider, because people are trying to compare Bitcoin, currency like Bitcoin with fiat currencies. Fiat currencies are like a dollar or a rupee, and they are trying to come up with these statistics. But we need to also consider how much money is spent and how much money is required to maintain the infrastructure of a fiat currency. For example, fiat currency requires central banks, and fiat currency requires printing of cash, and also how much money needs to be spent for transferring of the money, and how much money is spent for infrastructure like ATMs. Okay, so we need to consider all that and come up with a proper analysis. So it's again it's debatable. And there is one more limitation, that is money laundering. And currently there is no central authority to track the movement of assets. And in fact, that's the whole concept of blockchain. There will not be a central authority. So the blockchain are used by people for money laundering activities. Okay, so money laundering is nothing but converting black money to white. There are a few more limitations. For example, cryptojacked. So according to cyber firm McAfee, since miners need an increased amount of computing power to earn Bitcoin, some have started compromising public Wi-Fi network so that they can access devices to mine for Bitcoin. Okay, so a device can be cryptojacked. A device that is cryptojacked could have 100% of its resources used for mining, causing the devices to overheat, essentially destroying it. Okay, so these kind of incidents happen. And another limitation, one of the key feature of blockchain is that a blockchain's network of users is vast and constantly growing, which facilitates a stronger response to the attacks. So if the blockchain network is big and it is spanning across multiple geographies, then that kind of a blockchain is much more stronger, and it can repel the attacks. So in case a blockchain does not have a robust network with a well-distributed grid of nodes, it may not be possible to reap the full benefits of such a technology. So this is one of the concerns. So another concern, and the last concerns I have listed, is quantum computers. And at this point, this is a very theoretical concern, because quantum computers are not into effect at this moment. Okay, so now what is the concern? The quantum computers are considered to be 100 million. In blockchain, we talked about digital signatures, which are used for authorizing the transaction. Okay, and the digital signature is based on public key cryptography, where you have a public key and a private key, and public key is exposed to the public, whereas a private key is kept secret. Okay, and it means if somebody comes to know about your private key, they'll have all access to your funds. Okay, so it's usually it is impossible to derive a private key from a public key, but the other way around is not true. So which means you can't derive a private key from a public key. Okay, but using quantum computers, it has been said that it is possible to find out a private key from a public key. Okay, and the industry is working towards creating quantum safe cryptography. Is very theoretical in nature. The last but not least, we need to talk about blockchain for businesses. Okay, so far we discussed about mostly of public blockchain, okay, which is more inclined towards cryptocurrencies, but a few places I have given a references that suggest that blockchain can be used beyond cryptocurrencies and to record any type of transactions. Okay, now let's talk about blockchain for business and what is the problem currently facing businesses. Okay, now you take any business. Business never works in isolation. Okay, any business, take any business organization, they always work with different types of organizations, like it could be banks or it could be any third party. For example, take the case of a particular bank. Banks work with other banks, banks work with third party, and banks work with central banks. Okay, so take any business, they always deal with different type of business networks. Okay, and all the business kind of by connecting all these business networks, there is a lot of value. I mean, we are creating a lot of value by creating these by connecting these businesses. Okay, and the flow of goods between these business networks creates a lot of value. Okay, so this is one of the use cases for blockchains. Any business that has a business network, any business that has connections with different organizations is a good case for blockchain. Now let's take this example of as you can see in the picture, participant A and participant B, and this is a business network that I'm talking about. Okay, you have participant A is maintaining his own ledger, and participant B is maintaining his own ledger, and the banks maintaining their own ledger, and the insurer and the regulator and auditor all having their own ledgers. And this kind of a mechanism is very inefficient and expensive and vulnerable. Okay, and think about the amount of effort required to maintain these ledgers individually, and the amount of effort required for the process, etc. Okay, so now what benefits blockchain can bring for a business network? Okay, they can save time, the transactions time. It can bring down the transaction days from days to near instantaneous, and it removes the cost. Okay, and it reduces the risk, so which means fraud, cybercrime, and tampering, and it increases the trust because everybody are following a same shared business process and record keeping. Okay, and with these benefits, these are some of the key industry use cases for blockchain, and the blockchain can transform these industries like finance, the government, and healthcare, and insurance, and manufacturing, and also cross-industry use cases. For example, take the case of government. Think about land registries, okay, and vehicle registries, and think about a use case where where multiple departments will come into picture to validate something, or for example, you want to construct a bridge and you need clearances from a lot of departments, government departments. Then that's where the that's a good blockchain use case. And these are the some of the fields. These are some of the industries where blockchain can fit in. And I think that's all from my side today. I believe now you got some understanding of what is blockchain and how accounts are managed in the blockchain, who updates the blockchain, okay, what is a public blockchain and a private blockchain, and what are the use cases, and what problems blockchain can solve. Okay, thank you very much. Bye.